My name is Stephen Reed. I'm a senior account executive here at Progress Software. Before we get into the meat of knowledge graphs and knowledge modeling, I'm going to take a couple of minutes up front just to kind of set the framework for today's conversation. I'm going to take a look at a little bit of the traditional approach to AI, some of the limitations to that approach, and then how we can use knowledge graphs and knowledge modeling to strengthen those AI initiatives. So if you think about it for a moment, what's the real difference between a AI initiative at company A versus company B? Because if you think about the tools that are out there, the chat GPTs, the copilots, the Groks, all those, they're kind of accessible to anyone. So it's kind of like a level playing field from that perspective. Really what makes these projects different is how companies are integrating their private data with it. And that's really where the success of the generative AI projects are coming from, is being able to leverage private data effectively with my Gen AI tools. So why, therefore, are these projects so hard? Why are so many companies struggling to get the most out of their private data with their Gen AI initiatives? Well, there's a lot of reasons for this, but the way that I like to think about it, or the example that I like to think about it is, let's say, for example, I came to work for your company tomorrow. Well, how did I get to work for your company? Well, I probably went through an interviewing process, and we were able to have that interviewing process because we both spoke the same language, English. But once I started working for you, you're going to have to train me on all the acronyms that you use. I'm going to have to learn about all your different customers. I'm going to have to learn about all your different policies and procedures. I don't know any of that. You're going to have to teach me that information. Well, the Gen AIs of the world, they're absolutely no different. They don't have any understanding of any of those things too in your organization. So they don't know how to process your private data. So we have to figure out a way, well, how can we help them? How can we do that? If you think for a moment, though, and just take a quick step back, how the basic generative AI architecture work, it kind of looks like this. And you're probably all familiar with playing around with various tools yourselves, is you ask the Gen AI a question and it gives you a response back. And what I've found is, they're pretty good, I'll say, on things that are commonly known, kind of open source information. But once you start asking about anything around private data, these models start falling down really quickly, and you don't really get the right answers that you're looking for. Additionally, kind of these out-of-the-box generative AI tools have a lot of kind of built-in issues as well, too. Hallucinations is probably my favorite one. I think it's very industry that we as an industry had to come up with a term for that, because what is really hallucination? A hallucination is really just a really convincing wrong answer. That's really what a hallucination is. And we'll have an example of that in just a moment. But you have all these other issues as well, too, with out-of-the-box LLMs. Data biases, understanding data cutoffs, meaning I just am not getting the right information or don't have access to the right information in order to answer the questions. Explainability and robustness. And robustness really means is, did I really understand the question that's being asked? And the reality is, all these things can be either fixed or mitigated with the proper usage of private data. And that's really what we're talking about today, and how knowledge graphs and knowledge models can help that. But before getting into that, I wanted to do a quick example of a ChatGPT hallucination. This actually happened to me a couple weeks ago. Now, the body of the email is fabricated, the email address is fabricated, but the heart is really the same, which is someone sent me a note and said, "Hey, Stephen, can you please give me a call?" But they gave me an incomplete phone number. Now, I'd been in conversations with this person before, and I knew they were outside of the Denver, Colorado area. So I was trying to be a quote unquote good person, not respond back and say, "Hey, you guys, you sent me a bad phone number." I said, "You know what? This would probably be a great task for a chat GPT of the world to be able to answer, because how many area codes could there possibly be in Colorado that ends in the digits 08?" So I asked that question. Chat GPT happily gives me a response and says the only area code in Denver, Colorado that ends in 08 is 720. And it goes on and provides me a very detailed explanation of all the area codes in Denver, and reinforces the fact that the answer is area code 720. Well, that's obviously wrong. So the point is, even these quote unquote out of the box LLMs don't get it right all the time. And one way that can help them get it right is by feeding it the right information up front in order to make the best answer. So how do I improve the answers that I'm getting from my LLM models? Well, there's one of two ways to do it. I can either train my LLM models on my private data, or I can use an architecture called Retrieval-Augmented Generation, or RAG. If you train your own models, it's typically very costly, very time consuming. And then as soon as you're done training it, any net new information is, of course, not available to the LLM. So you don't have the relevance, or you don't have the most timely data at any given time if you take that path. Conversely, if you go down the RAG path, you can always send it the most relevant data, assuming that you can find it quickly and accurately. And RAG takes advantage of something called the token window. So the token window is more commonly known as the concept of prompt engineering. So this is when you're typing in all your information to the chat GPT or the Groks of the world and say, hey, I want you to respond to this question using this type of writing style, blah, blah, blah. That's your kind of your prompt window or your token window. Now, when you're doing that on the back end, what's happening is the computer's converting basically your text into a string of digits or tokens. And those tokens may or may not have an exact one-to-one mapping between words, but you can kind of think of it, there's, each word that you're typing is being converted into a numerical value. And those tokens is actually what's being sent to the Gen AI as part of the prompt window. Now, depending on what LLM you're using, these token windows can be of various sizes. But there's a couple things to remember. None of them are infinitely large, so they're all finite. So I can't, send all my information, all my private data to the token windows for processing. And the other thing we have to recall too, or keep in mind, is that the amount of information I send in these token windows is directly proportional to the cost and processing and response time of the LLMs. So even if I did have an infinitely large token window, it would be impractical to use because I'd be basically waiting forever in order to get a response. So really, what I'm trying to do with this prompt engineering through these token windows is not sending all the data. I want to just send the right data to the LLM to give me the best response. So then the question becomes, how do I find the right data to send? Well, that's where knowledge graphs really can help us solve this problem. All right. And knowledge graphs, you can kind of think of them as two pieces. One is basically a data index, where it's basically a way to represent or reference all the private data you have within your organization. And then you basically have a taxonomy or knowledge model that basically describes the relationships of that data. And we'll talk a little bit more about that before we get into Jim's demonstration. But basically, that's step one of the process. I need to have a graph representation of my private data. And that allows me to be able to understand it so that when someone comes along with a user query and says, hey, I want to be able to answer this question, I can quickly search that graph database and say, hey, what's the most relevant private data that I have that I can then send to the generative AI inside the token window to provide me with the best response. And when you do that, we're seeing very, very high results in accuracy with these private data approaches using a graph RAG architecture. So we're really going to be focused for the rest of the time today on this box here, Semaphore. Semaphore is our taxonomy/knowledge modeling tool. It describes the relationships that I have in my private data. And we're going to talk about just a couple terms first, and then I'll be turning things over to Jim for a live demonstration. So first of all, let's talk about, well, what actually is a knowledge graph? Well, if you think about the data that you have right now, a lot of people think about this term data silos, meaning I have isolated and independent data. And that can happen over time. It can happen through acquisitions. It can happen because of every time I spring up a new application, I may need a new data repository, a type of data to support that. So I don't really have a good way of connecting that data. What a graph does is it allows us to connect the data across my data silos. So the example that I always give here is I say, how many ways can you think about the concept or the data idea of a social security number, right? It might be stored as employee identification number in one database. It might be taxpayer identification number in another database. And inside my employee resources file, it could be social security number. But it's all talking about the same concept. They're all semantically linked, meaning they have the same semantic meaning. So then how are these relationships described in these different data silos once we connect them together? Those relationships are defined by a taxonomy or a knowledge model. So that begs the question then, well, what is a taxonomy or a knowledge model? You don't have to overthink it too much, but basically a taxonomy or knowledge model is just a way to group information so it's in a logical category. It can be easily referenced, searched, potentially even distributed. So my favorite example here is the next time you walk into a grocery store, you're actually walking into a taxonomy. Okay, there is a reason grocery stores don't sort their food or itemize their food alphabetically. That wouldn't make any sense, right? You're not going to find a steak in the same aisle as you would as a can of soup, right? They have departments: produce, meat, dry goods, because that is a logical way and makes sense in the terms of a grocery store of how to organize information. So once I basically have a way to describe the relationships between my various data, I have a way to basically index that data and make those relationships known through a knowledge model. Then basically I have the core pieces of what I need to construct a knowledge graph. Now, this is a little bit more sophisticated version. You can kind of see, oh, I have much more, I'll say much more flushed out concepts, but then you'll also see that I have the relationships between these concepts analyzed as well too. So I have a way of representing not only what the data item is, but how it's related to other things in my organization or how it's related to potentially other data repositories as well too. So that's kind of a working definition that we have for knowledge graph, for taxonomy, and for knowledge models.